In this lesson video, we are going to add light sources to our robot scene and then render it. This is what we have so far after the modeling process and adding the materials. To preview the lighting in our scene, we should be in the rendered view mode. But before we add any light sources into our scene, we need to make sure that all of our reference objects, which are these objects, do not show up when we do the final rendering. To do this easily, we can deactivate the rendering checkbox of the collection. By default, the rendering checkboxes are not visible. To show them, we can click this button up here, and then turn this option that looks like a camera on. We can see that by default, the ref collection has the rendered option turned on. Just click this to turn it off. And now, the whole ref collection will not be visible in the final rendering. Next, let's focus on the environment light. We can see that the environment light is too dull. This is because if we go to the World Properties panel, it only uses this solid gray color as the light source. We want to use an HDRI file for the environment light. We've discussed this many times before, so you should already be familiar with the process. Click this small button. Use the environment texture node. It looks pink now because we haven't assigned any HDRI file. Click the open button. I have a special folder where I put all of the HDRI files that I downloaded from hdriheaven.com. Let's pick this one because I kind of like the trees here, which gives a nice variation of speculars on the reflections. If you want to use the same HDRI file that I use here, you can download it from hdriheaven.com. The file name is Bethnal Green Entrance. Okay, now we have a nice environment light, but we actually don't need to see the background. So go to the Render Properties panel. In the Film section, turn on the transparent option here. Next, we want to have subtle shadows on crevices or on surface intersections. For this, we can turn on the ambient occlusion option here. Next, turn on the screen space reflection. Then, we can use the bloom effects here to add glowing visual effects automatically on light emitting materials or on reflections where strong lights appear. Next, we want to add two lights. First is the key light and second is the backlight. Press Shift A and then choose light and then choose area here. Basically, area light is a type of light source in Blender that emits lights from a defined area, not from a single point. It can be from a square, rectangle, circle, etc. Let's rename the light object to light.key, just to make things more organized in the outliner. For the light settings, let's change the color to a bright yellow color. For the power, let's crank this up to 100 watts. For the size, let's make it 2 meters. As you can see, the light is currently facing down. Let's rotate this on the x-axis. Press R, then X, and then type 90, then enter. Go to the front view, G, and then Z, and then move this up like so. Go to the top view, and move the light to about this location. Rotate it, and try to make it facing the robot. Next, we want to add a backlight at this side. We can just duplicate the existing key light, so Shift D, and move it to about this location. Then rotate this so it is roughly facing the robot. For the backlight, we don't want to have the same yellow color. Let's pick a bluish color. Next, we want to make this light not square, but more like a strip of vertical light. To do this, we need to change the shape from square to rectangle. Due to this, we can now set the X and Y values separately. For the X, let's input 1 meter, and for the Y, let's make it 2 meters. Feel free to experiment with the light settings. For me, I consider this good enough, so I'll move on with this one. Next, to be able to final render this robot, we need a camera. Shift A, and then choose camera here. Then try to find the best viewport angle for the final rendering. I think I like this one. Maybe zoom out a little. I want to show this area and also the leg curve clearly. After you like the view, press Ctrl Alt 0 to align the camera to the current view. We can see some clipping occurs in the camera view. To move the camera back a little, we can press G, then Z twice to activate the local Z-axis constraint. Then move this back so that the whole robot is in frame. You can press G to pan the camera. Next, we want to achieve more realism by adding global illumination or indirect lighting to the scene. As we discussed before, Eevee is a real-time renderer. Unlike Cycles, which is a full path tracer, in Eevee, indirect lighting does not available out of the box. We need to bake it first, or for better terms, we need to calculate it and save it in a memory before we do any rendering. If you used game engines like Unity, Unreal, or Godot before, you should already be familiar with this process. Okay, so to do this, press Shift-A, Light Probe, and then choose Irradiance Volume. Next, we need to make this Irradiance Volume object to cover the entire robot. Go to Front View, move this up, and then scale it until the inner box covers the whole robot. The claws are still partly outside the inner box. We can scale this only on the x-axis to fix it. If you are wondering what this irradiance volume does actually, well, the most important part of this object is these little dots here, or also known as probes. When later we do the baking, each of these probes will store the lighting information based on the surrounding surfaces and their colors. Essentially, the more dots we have, the more precise the result will be, but at the cost of longer baking time. Currently, we have 4 by 4 by 4 probes inside the volume. Let's increase this value, but not too much. We can click drag like so, and then type in 8, then enter. Now we have 8 by 8 by 8 probes inside the irradiance volume object. Next, to actually make use of these probes, we need to bake the indirect lighting. To do this, we need to go to the rendering panel, open the indirect lighting section, and then click this button, Bake Indirect Lighting. Now Blender is calculating the indirect lighting information and store them to each of the light probes. We can see the baking progress down here. Depending on how fast your computer is and how many light probes need to be calculated, this can take a while. And we are done. It looks good, so let's just do the final rendering. Press F12, and it is done. The cool thing about Eevee is that because we already baked the global illumination before, it will perform the rendering almost instantly. To save the image, just as we discussed before, we can go to the image menu, then save as. You can name this to any name you like. I'll name mine with the lesson code so later you can find the file easier. Make sure you have the default setting, which is PNG format with RGBA mode. This way, you can store the transparency information and use the image for later compositing in any 2D graphic application way easier. And yeah, I think we are done. Oh, sorry, I forgot to rename the backlight object. Let's rename this to light.back. And alhamdulillah, we are now done.